Hello, calculus fans! So in the previous section, we learned the direct substitution property. Sometimes we can just plug in the limit point into the function to get the value of the limit. Functions where you're allowed to do this are called continuous, or we'll say continuous at x equals a. Here's the definition of continuity. So we're going to say that a function is continuous at x equals a if three things. F of a is defined. Another way of saying that is that a is in the domain of f of x. We also need the limit as x approaches a of f of x to exist. We also need the limit as x approaches a of f of x to actually equal f of a. So a continuous function has the property that a small change in x produces only a small change in f of x. If f of x is defined near x equals a, in other words, if f of x is defined on an open interval containing x equals a, except possibly at a, then we're going to say that f of x is discontinuous at x equals a. Or another way of saying this is that f of x has a discontinuity at x equals a if f of x is not continuous. So not continuous, we're going to use the word discontinuous. Now, most real-world phenomena are continuous. The position, velocity, and acceleration of moving objects, those are continuous functions of time. The level of water in a tank, if you're filling it with water, it's a continuous function of time. Discontinuities, however, they do happen in electric currents. So we talked about the Heaviside function earlier. This models an electric circuit. It's a discontinuous function because the limit as t goes to 0 of h of t does not exist. I like to think heuristically, continuous functions are those whose graphs have no breaks in them. And that means we can draw the graph without lifting our pencil from the paper. Okay, that's all for now.